So, last class I have started detailed site investigation. It includes planning, making test boreholes, collection of soil samples and laboratory test. Also we have discussed number of boreholes to be decided and depth of the boreholes. Now there are different boring techniques. So, I will go one by one. So, if I go this boring, first one as I said, it is a trial pit. In this trial pit, generally make a pit of 1 meter by 1 meter by 1 meter, then push these sampler tubes inside the ground surface. That means the sampler tube has to be pushed inside the pit. Remember, it has to be pushed, not it has not going to be hammered. So, basically what does it mean by doing this pit sampling? So, trial pits you are getting stratifications of the pit. From the side you can get it whether any change in soil stratification or not, and at the same time you can collect also undisturbed soil samples. So, it is only possible when soil of soft or medium consistency. If it is hard, it is not possible, and it will be suitable for a shallow surface explorations. This is the case of your trial pit. Now, go to wash boring. Second part is your technique wash boring. This is your wash boring. In wash boring, let me draw this diagram, then you can have some idea. So, in wash boring, the technique, the borehole of 150 to 200 meter dia drill through, and generally the soil is loosened and removed from the borehole by stream of water. That means it is a parallel process. You are doing a borehole, at the same time these are the stream of water you are injecting inside one side, and other side the soil loosen, and other side soil with water, it will come out and settle in a settling tank, and then as it settle down over the period of time, from the settling tank you can take or you can push your sampling tube to collect undisturbed soil sample, I cannot say it undisturbed soil sample, rather it will be a molded soil sample, it will be a remolded soil samples. So, if you can imagine where it is possible for this your wash borings, wash boring particularly a hard soil where it will be very difficult, kind of very difficult hard or stiff, very difficult to collect undisturbed soil samples, it will be very difficult to push your sampling tube. In that case, in localize you make a borehole, then wash pipe inside you put it, one side you inject your water. So, with water the soil will be loosened and other side soil, water, mud will be flow out and it will settle down in a settling tank. Then you leave it, that means you first disturb it, then take it out, then you leave it, then water will be percolated below your settling tank. So, only soil will be there. Then what will happen? This soil will be again remolded, then after remolded you take out your undisturbed soil sample and do your test. The detailed merits and demerits, particularly trial pit, wash boring, auger boring, I will discuss later part. Also about your sampler tubes, different sampling tubes has been used to collect your undisturbed soil samples, that also I am going to discuss next, means in the further future classes. So, third one is your auger boring. Auger boring, if I draw it, so there is a borehole, then this auger, then there is a handle here, so there are two types of auger boring, one is manually, other is mechanically. So, in case of manually, in India manpower is labor cheap, so generally people prefer for manually. What will happen by means of auger? If you look at the base there are blades, at the end there are blades like this. So, you push it inside and rotate it by means of handle, so it will try to cut it. So, then soil will go inside, then you push it inside. So, in this way what will happen? You are going to make boreholes up to your requisite depth. Then once you have made your borehole, suppose it is required to go for borehole or maybe collect your soil sample, for example up to 10 meter depth, 10 meter depth, and you need to collect soil sample every 2 meter depth. So, what you are supposed to do by means of auger boring, either it is a manually or mechanically. So, take the auger, bore it, make your borehole up to 2 meter depth, then once after 2 meter take out this auger, remove this auger, then at the base after removing there are arrangement here, you can connect it sampling tubes. Generally sampling tubes are of size this part I am going to discuss later. Then connect it sampling tube, then lower down your sampling tube up to 2 meter depth, then push it so that soil will go inside, so that you can collect undisturbed soil sample. So, this way 2 meter in auger boring, doing borehole, then detach your auger part, attach your sampler tube, collect undisturbed soil sample, then detach sampler tube, then connect auger, then again drill, go up to 4 meter, then again take out your auger, connect sampling tube, collect your undisturbed soil sample. This way auger boring generally it has to be done. So, In India, generally auger boring mechanically, manually people do it, because manually what happened, two persons will be there, this is your handle, they will just rotate it, they rotate it so that auger will go down. Then this is your rotary drilling. It is generally done by means of drill bits and it is advanced. This I am going to show you some PPT, PowerPoint presentations as well as videos. So, whether it is a hard stratum, whether it is a soft stratum, by means of drill bits you can make bore holes, at the same time you can collect undisturbed soil samples at any depth. So, it can be used of any kind of soil, it can be used sand, it can be used clay, it can be used for intact rock, intact rocks. So, this is well advanced. This generally people take it by means of truck, attach it in a truck and take it out and do it. It is a advantage of this rotary drilling, within no time you can finish it. This will be slightly costlier as compared to auger boring, because what will happen, auger boring, it takes time. Generally India people prefer to do it by means of manually. Here it has to be done by means of rotary drill by machines, push it inside, drill it, make bore hole, then collect undisturbed soil samples at regular interval and come out. I will start next. What are the different field testing of soils? First one is your relative density. It is for granular soil. For relative density, what are the tests to be carried out? This is called SPT. Full form is your standard penetration test. For UG, this is a new term. You are learning a new terminology, SPT, standard penetration test. Then second one is your dynamic cone test, is your relative density. Second one is your shear strength in situ conditions, that means in field. There are two parts, one is your laboratory, one is your field. Particularly cohesive soil. So, what are the tests in the field? Bend test, second one is your direct shear test, third one is your static cone test. Then bearing capacity and settlement. This is your plate load test. Then permeability, boreholes and piezometer test. Then testing of piles, pile load test, then compaction control, moisture density, then severe test, then in situ strength and deformation characteristics of soil, in situ strength and deformation characteristics. In this case, pressure meter test, then dilatometer test. There are many other part. I am going to let me finish it, then I can make it. Then dynamic properties, shear velocity Vs, shear velocity Vs, low strength shear modulus G0, seismic downhole test, seismic cross hole test. Then your machine foundations, for machine foundations block vibration test. If I make it into two component, particularly geotechnical investigations and subsoil explorations, I can say it. First one is your collection of soils. Earlier I have said either it is disturbed or undisturbed. Then from there, from collection of soil samples, you can do it laboratory test. Sometimes while collecting the soil samples and doing the laboratory test, the soil samples become remolded. It is not giving a true state of your soil inside your ground surface. Why? Because, for example, let us say for example this. Here you are collecting undisturbed sample at a depth say 5 meter. This is your undisturbed sample you are collecting at a depth of 5 meter. So, before collecting what happened? What is the physics? There will be a vertical stress, there will be all round confining pressures. The moment you take out the soil, undisturbed soil sample from here by sampler tubes, this is my sampler tube. Inside the sampler tube you have collected your undisturbed soil samples. So, what will happen once I am taking out from the ground surface? Its confinement lost. That means overburden pressure, it is lost, confining pressure, it is lost. Then I am taking to the laboratory and making arrangement of calculating what is its overburden, what is its confinement, and I am applying. By that time from here to I am taking to laboratory, the soil has lost its confinement. At the same time there is a temperature here below the ground surface. Once I am taking out till putting in the laboratory, there is also loss in temperatures. So, this may not give the true value of your engineering properties of the soils. Sometimes it require actual test in the field. So, then your field test. So, first one is your boring, boreholes, collection of soil sample disturbed, undisturbed. Then there are two parts. As I said earlier, the cost of the testing or soft soil explorations, it will be 0.1 to 0.5% of total cost of your entire building or entire structures. So, you cannot spend more. Then here laboratory test, second part is your field test. Whenever it is required for field test, you go for a field test. Now, if I come back, field testing program of your soil. So, what are the different tests we are supposed to conduct? For to know your relative density, it is particularly your granular soils, phi soils, it has been extended for C5 soils also. So, SPT, this is called standard penetration test. We will go in details all the tests. Standard penetration test means penetration values, then dynamic cone test, shear strength cohesive. Shear strength cohesive you can measure in the laboratory, absolutely no problem. Shear strength sometimes cohesive soils, it is required to measure in the field. So, it will be Venn shear test, direct shear test you can do it. Direct shear test you know in your soil mechanics you have conducted in previous semester, direct shear test also. This also can be done in the field, Venn shear test, direct shear test as well as static cone test. This is your cone penetration test, sometimes you say CPT. Dynamic cone test is different than CPT cone penetration test. Now, bearing capacity and settlement, in situ bearing capacity and settlement, if somebody asks there is a ground, I am going to construct a building and below 2 meter I want to lay my foundation. So, what is the bearing capacity of the soil below 2 meter? So, in that case you have to go for plate load test, plate bearing test, every test having merits and demerits, we will discuss in brief. Then permeability, permeability where it is required, dams, reservoirs, their permeability is major factor, because if you do not know the permeability, then your flow channel, flow field, it will create problem. In that case you can go by means of boreholes or piezometer test. Testing of piles, testing of piles is required for your deep foundations. In that case you have to go for a pile load test, real pile load test in the particularly in your site and find it out its bearing capacity. Then compaction control where it has been used, example road, embankment. What you are doing in compaction control in the laboratory, you are doing by means of Proctor compactions and modified compactions. So, these are all laboratory based. As I said just before, there are limitations in your laboratory test. So, here actually whatever you have done in the laboratory test, whether it will going to same parameter it is giving in the field, then there are two tests. One is your moisture density, other is your CBR test. CBR full form is your California bearing ratio test. Then in situ strength and deformation characteristics. In situ strength, if you look at your bearing capacity also in situ strength, this is for your shallow depth. For a deeper, you can go for a pressure meter test. What you are supposed to measure it? K0, E modulus of elasticity, strength parameter as well as your deformations. Then dilatometer test. For dynamic conditions, particularly response analysis, liquefactions, earthquakes, you need certain values. Shear velocity, E, mu and G, these are the parameters required for your modeling. So, dynamic shear modulus G0. So, there are two field tests available, seismic downhole, seismic cross hole. Also there are many also available, generally this is as per your ASTM standard. Sometimes you want to go for a machine foundations. So, in case of machine foundations, what are the tests you have to do? Block vibration test. There are also many other tests are there, that also in brief I will discuss. Seismic refractions, seismic reflection test to find it out your water table. Then ground penetration radar GPR, that also required for geological point of view. There are many field tests, particularly the advantage of your field test to do your field test, these are giving without having any scale effect, without having overburden pressure lost or confinement lost. This will give you a true value inside the ground surface, the parameters. So, these test in brief, because this is a foundation design, unless if you do not know from these parameters, then you have to recommend as a geotechnical engineer, okay fine, I will go for one borehole, I will collect soil sample below 10 meter, at the same time I will do one test, field test, standard penetration test. It gives me penetration value. Okay, I will not do the standard penetration test, rather I will do it one test, that is my plate load test, that will give bearing capacity and settlement. So, these values will be required for your modeling, for your foundation design as well as analysis. That is why this has to be finished within certain period of, means very briefly, so that my emphasis will be on foundation design as well as analysis. Let me start one of the field test program, that is your plate bearing test. Plate load test, or called plate bearing test. So, plate bearing test, what you are supposed to get? You are supposed to get bearing capacity, settlement, differential settlement, E, subgrade modulus K, then influence factor. These are all parameters you are supposed to get with a single test, plate bearing test. There are scale effect. So, this test covers widely. If I do a test, plate load test at the shallow surface, I can say that okay, at 2 meter or 5 meter depth, bearing capacity of soil is this, my structural load is coming this. What is the permissible settlement? What would be the settlement? What is the differential settlement? From load versus settlement curves, I am supposed to get modulus of elasticity, subgrade modulus as well as differential settlement, from not from load versus settlement curve. Load versus settlement curves, I am supposed to get EK. These are the things I am going to discuss in the next class. I will start the field test one by one, but now I am going to in brief, not in details, because my emphasis will be more on foundation design and analysis modeling part, rather these will be in brief, so that these parameters are input parameter for your foundation design and analysis. Thank you.